Review problems 8 and 9. Are these two triangles similar? I don't know. Let's find out. All right. So, again, I see two lines that intersect, which means my very favorite, vertical angles. I definitely know these vertical angles are true. So, out of my criterion, I'm hoping to use side equal side because I have two sides and I have an equal angle. So, let's test. Let's use the method I used before where I see two triangles. Hopefully you see two triangles. I see two triangles, you see. So I'm going to take the longer sides out of both this slightly bigger triangle, and I'll call this the lower triangle, and I'll call this the upper triangle. So the lower triangle has the longest length of 21, and then the upper triangle has the longest length of 14. And then let's see if that's proportional to the smaller length of 15 to 10. So if you look at this, these two numbers have factors of 7, which is really good because then you can do divide by 7 on both the numerator and denominator, you get 3 over 2. And these two have the greatest common factor of 5. And if you take a 5 out of 15 and 10, you will get 3 over 2. Boom, proportional. Yes. Now, the tricky part is deciding what the order is. All we know is that, let's start with H. So H is on the end of the longest, it's on the end of the longest length. So here's X is on the end of the longest length. We know that Y is in the middle for both of them. That's the angle that they have in common. And then the other letter, the last letter. Remember, if you don't have these letters in the exact order, it is not necessarily true. In fact, it is not necessarily true. All the points have to correspond. So if your answer has H corresponding with X, Y corresponding with Y, and J corresponding with Z, there's actually two options. There's only two options here. Why am I explaining it this way? There's only two options. You have to have one of these two answers. oh, that's not it. X. Okay, by side and side. Number 9. Similar, yes or no? I don't know. Let's find out. If yes, tell me which triangles are congruent and by which property. All I see are sides. Oh, I see a common angle. Nice. So I'm hoping this is side angle side. Now, this says sketch little triangle, sketch bit. These are training wheels. I think this was designed for like young children, like 9th graders, like back in the LPS day. So that's why this says it here. Let's do this like big 11th grade geometry, folks. All right. I see two triangles. They overlap. You see two triangles that overlap? Good. I see a little triangle and a big triangle. Little triangle, big triangle. Now, let's do, for the little triangle, I see E and F. I'll write it. E and F is the side of the triangle. It's corresponding with I and F. This is the bigger side. This is the smaller side. So let's see if the other side of the triangle, G and F, is proportional to H and F. So the top numerator numbers are from the small triangle. The denominator numbers are coming from the big triangle. And this is the left side of the triangles, and this is the right side of the triangles. So EF is easy, 4. IF is not 2, and it's not 4. It's 2 plus 4, 6. You see how IF is this entire length, 2 and 4? Oh. So G and F is 6. That one's easy. But H and F is both of these values combined. All right, let's simplify this. Greatest common factor in both of these numbers is 2, so you're left with 2 over 3. The greatest common factor of these two numbers is 3, so you're left with 2 over 3. Yes, they are proportional. Let's start with E corresponds with I. F corresponds with F. And G corresponds with H. Ta-da! That's an E. Oh, yeah. All right. So, yes.